Hello. In this video, we want to find the derivative of the following function. We have s of t is equal to log base 8 of t to the 3/2 power plus 1. And then all of that will be divided by t. Awesome. So to do this, first of all, we need to realize that this s of t here is a logarithm divided by a polynomial. In other words, it is a quotient here. And we need to use the quotient rule. Now the quotient says that if y is u over v, or the quotient rule says, is if a function is y equals u over v, then y prime is going to be v u prime minus u v prime, and then all over v squared. Awesome. So let's do that. Now the numerator here is going to be log base 8 of t to the 3/2 plus 1. The denominator will be t. So to find s prime of t here, we're going to start out with just writing down the denominator t, and then multiplying by the derivative of the numerator. Now the numerator here is log base 8 of t to the 3/2 plus 1. Notice that there is a base 8 here, and so what I'm going to do is multiply this t by, and in the denominator you will have the natural log of the base 8, and then also in the denominator I'm going to go ahead and write down the entire t to the 3/2 plus 1. Excellent. So that's the denominator. The numerator is the derivative of the argument. So bring the 3/2 down in front, which makes that 3/2. T to the 3/2 minus 1 is 1/2. Good, and then this plus 1 is the derivative of that is 0, so it doesn't get written. Excellent, so we just did the first part here. V times u prime. Now let's do minus u, which is the numerator. So we'll have log base 8 of t to the 3/2 minus 1, sorry, plus 1. Close parentheses, and then times the derivative of the bottom. But the bottom is t, so the derivative of t is just 1, so just times 1. And then all over t squared. Awesome. Let's see how this simplifies. Okay, so what I want to do is I want to realize that, first of all, we've got some weirdness going on here. Second of all, this t can multiply by this t to the 1/2, making that t to the 3/2. And if I really want to, I can do the following. So making this 3/2 t to the 3/2 all over natural log of 8 times t to the 3/2 plus 1 minus, and then log base 8 of t to the 3/2 plus 1, all over t squared. Now, this is what we call a complex fraction, and we don't like complex fractions. To get rid of the complex fraction, we look at each term individually. Now we have a term here, we have a term here, and we have a term here. There's only one denominator for each of those terms, and that's all of this right here. So what I'm going to do is I'm going to say everything in here gets multiplied by that denominator. So I'm going to multiply both the numerator and denominator by the same thing, which is going to be the natural log of 8 times t to the 3/2 plus 1 in both numerator and denominator. Good. Now, notice that this will distribute to both of these and also to that right there. But the important thing is that this entire thing right here will cancel all of that right there. So this denominator goes away here. So this is going to give me the following. 3/2 t to the 3/2. And that's it for the first term. And then now notice that minus, none of these need to multiply together. These are all factors. Logarithm, you can never break the argument away from the logarithm. Natural log of 8 is just a number, and this is already factored. So just leave it like that. So that makes that log base 8 of t to the 3 halves plus 1 times the natural log of 8 times t to the 3 halves plus 1. And that's the numerator. The denominator, again, no need to multiply all this out. So if we don't multiply it out, we just have left over t squared times the natural log of 8, which I'm going to put out front because that's a coefficient, and then times t to the 3 halves plus 1. And there you go. Is that S? Yeah. So here is S prime of t, which is really fun, honestly. It's a very interesting question. Alrighty. Well, I believe I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.